Hello guys. In this video I'm going to be talking about section 11.2, surface area of prisms and cylinders. You may notice that we skipped section 11.1. That's about a formula called Euler's formula. It's kind of interesting, but you won't see an application for that very much, so we skipped it and we're going to surface area of prisms and cylinders. All right, the first one. This is a rectangular prism. If you want to draw it so you can see the innards, you can. You don't have to, but it might help you understand what's happening a little bit better. You can either use this formula specifically for rectangular prisms, or you can use this formula that works for all prisms. I put other prisms just because that's what I use it for. I use it for all the other ones, the triangular ones and the polygonal ones. All right, so let's do this one. So I'm going to use this formula, and I'm going to replace 12 for length, 4 for width, 8 for height. So 2 times length times height plus 2 times width times height plus 2 times length times width. And when I use this formula, since it's so long and so many numbers, I just make sure that I've paired them up. So 12 and 8, that's one pair. 4 and 8, that's another pair. 12 and 4, that's another pair. Just make sure you paired them up and didn't duplicate any of them. All right, so what's actually happening is you're finding the area of this front face, 12 by 8, and there's 2 of them, a front and a back. And you're finding the area of this right side, and there's 2 of them, left and right, and you're finding the area of this bottom, 12 by 4, this base here, and there's a top and a bottom. So that's why there's a 2 in front of each of these parts. You can punch that into your calculator exactly like that. So 2 parenthesis 12 parenthesis 8, like that, plus 2 parenthesis 4. And if you don't like typing in all these parentheses, you can put times in the middle of all those instead. Times 4. And then you press equals and it does it for you. It is 352 inches squared. Now, if you had chosen to use this formula instead, the perimeter of the base would go here. That's 12 plus 4 plus 12 plus 4. That would go in this spot. The 8 would go here. And remember, this capital B means the area of the base. And since the base is a rectangle, it would be length times width. And that would be 48. So 48 would go here. And if you do that, that formula will also work for this problem. So it depends on which one you prefer. Example 2. So this is a cube. A cube is also a rectangular prism, so you can use the same formula that I just used if you would like. And you can also use the one, I didn't write this down, but you can use this formula, 6s squared. So you may want to add in here on the notes that for a cube, you can also use 6s squared. So what's happening is you're finding the area of one face, which would be a 6 by 6 rectangle. And since they're all 6 by 6 rectangles and there's 6 of them, that's why there's a 6 in front. So that formula is probably the shortest one to do. And so I'm going to do that one. 6s squared. That'll be 6 times 6 squared. And that is 6 times 36. And that gives you 216. 216 inches squared. These are all going to be units squared because they are surface area. If you had used that formula, you would have 2 times 6 times 6, and 2 times 6 times 6, and 2 times 6 times 6, and you get the same answer. And if you use this formula, you would also get the same answer. So it is completely up to you. Example 3. So this one, you have to use the one called other prisms. So this is for triangular prisms and all the ones with polygon bases. They call them the polygonal prisms, polygon bases. This is a pentagonal prism. All right, so I'm going to write down the formula first. Surface area equals capital P times H plus 2 capital B. Capital P is perimeter of the base. capital B is area of the base. So there's a lot about this base right here. So there's so much in the formula from this base that I like to draw that base as if I'm only looking at that one thing. And then I can think about what I need from it a little bit better, because that's all I'm looking at. So since this is a regular pentagon, all these sides are 10, and that makes capital P 50. And then the height of the prism is 12. And that is 600. Okay, just a little mental math note. To multiply that kind of quickly, I do 12 times 100, which is 1200, and then I half it because I'm only multiplying by 50 instead of by 100. So that's just a little mental math note for those of you who like to do things quickly. All right, I need area of the base. This is where the work comes in. So to find the area of a regular pentagon, you have to use this formula, 1/2 perimeter times apothem. And so that was that part in chapter 10 that took a little bit of work. So, so let's talk about that. We already know what capital P is. It's 50. So it's still 50, but I don't have the apothem. So I have to do this chapter 10 work to get this missing apothem. So this triangle, since there's 5 of them, if you take 360 and divide it by 5, you get 72 degrees right there. So that angle is 72 degrees. And then when you draw in the apothem, which I need to find, it cuts that angle in half and it cuts the 10 in half. So this triangle right here is a 5 and a 36. And I'm looking for this apothem. So, sorry, that's a little crammed in there. All right, to get that apothem, since that's a 36-degree angle, it's not special 30, 60, or 45. I have to use trigonometry. And across from it is the 5. And right next to it, adjacent to it, is the A, which is what I'm looking for. So this is a tangent problem. So I'm going to come over here and write tangent of 36 degrees is equal to opposite over adjacent. Whenever the variable is on the bottom, you divide. So grab your calculator and do 5 divided by tangent 36. And you get this number, 6.8819. That's the apothem. 6.8819. And multiply that by half of 50, and you've got the area of that pentagon. So multiply that by 25. 172.0477. Now I'm going to leave it with several decimal points just so I'm going to round it that final answer. So 172.0477. That is 1/2 perimeter times apothem. So that's the area of the whole pentagon. And there are 2 of those. So that's what goes right here. 172, blah, blah, blah. Okay, so since that's already in my calculator, I'm going to multiply it by 2, because that's what I'm doing here. You get 344.0954. You can write that down. Blah, blah, blah. And since it's already in there, now I'm going to add 600, because that's what the formula says. And you get this. This is where I'm going to round. 944.1. It's approximately 944.1 centimeters squared. Now, that is a monster. So you have to show all this work. And you can see now why I took that pentagon and drew it by itself, so that I could kind of think about this work a little independently from what I'm actually trying to do at the beginning. So there's a lot there, so you need to show all this. Okay. The next one is a cylinder. Cylinders are much easier. This is the formula. So surface area equals 2 pi RH plus 2 pi r squared. 2 pi, the radius is 2, the height is 11. And then this one, 2 pi, the radius is 2. So this is all multiplying right here. You can multiply in any order because it's commutative. So you can do 2 times 11, which is 44 pi. This one, you have to do the squaring first. Now with 2's, it won't much matter. But when there's, a 3 or a 5, make sure you square this first. So this is 4 times 2, which is 8 pi. And then when you add those, you get 52 pi meters squared. Now you can leave your answer like that. Or if they ask you to round in the question, then you'll round it to 163.4. So approximately 163.4 meters squared. So either one of these answers would be acceptable. It all just depends on what the question is asking you. All right, one more. This one confuses people because a lot of people, they'll make the mistake of using the pyramid formula, but this is a triangular prism. It's just laying on one of its rectangle faces. This is the base. So you can tell bases because there's always 2 that match. So I think the rectangles are what confuse people because you could use any side as a base. But like this one, the 2 pentagons match, those are the bases. And here, the 2 circles match. Those are the bases. Here, the 2 triangles match. Those are across from each other, same triangle. So this is, that made it look worse. This is a triangular prism. So this is what they're talking about when they talk about the base. All right, so you have to use the formula that says other prisms. And so we're going to plug in perimeter of the base. Now the base is this triangle. And again, since there's a lot to do with this base, it wouldn't hurt to draw it separate like that. So we need the perimeter of the base. Well, we only have this side is 3 and this side is 5. This is blank. So if you happen to remember, my picture's not to scale, you can tell. If you happen to remember the Pythagorean triples, there's one Pythagorean triple that's a 3, 4, 5. So this would be 4. If you did not remember that, let's pretend for a minute you don't remember that. It would be a squared plus b squared equals c squared. 5 is c, so a squared plus 3 squared equals 5 squared. That's a 9 and a 25. And when you subtract 9 from both sides, you get 16. And then when you square root, you get a is 4. So if you didn't remember a 3, 4, 5, your Pythagorean theorem work will tell you that this is a 4. So the perimeter of the base is 3 and 4 and 5. So that's 12. So that's what perimeter is, just adding up the sides. And then the height of the prism. Now, this gets a little confusing because it's laying down, but you have to imagine that this prism is standing up on this triangle base. Remember, the triangle is the base. So if you stand it up on this as the base, that's how tall it is. And then we need capital B, which is area of the base. All right, so since the base is a triangle, the area formula for it is 1/2 base times height of the triangle. Now remember, this little b and this little h is talking about the triangle. You can't use 5 for the base of the triangle because we don't know how tall it is. But we learned when we did area that in a right triangle, the legs can always be used as the bases. So see, if I sat it on the base of 3, the 4 is how tall it is. Or if I sat it on the base of 4, the 3 is how tall it is. So you can use the 3 and the 4 as the base and the height. So 1/2 times 3 times 4. And that is half of 12, which is 6. Now remember, that's the area of the triangle, because that's the area formula, 1/2 base times height. And that's what capital B is. Capital B is the area of the base, and the base is a triangle. So that is 6. So what you get is 72 plus 12, and that is 84 centimeters squared. So the work is going to be right here. It's going to be finding the area of this base, and especially when the area is, or the base, I mean, is a regular polygon, it's going to take some work, like we did in Chapter 10, to find those missing pieces to find that area. All right, so that is section 11.2. So there will be a worksheet about this to do for practice, and that's what you'll turn in. So y'all have a great day.